Behind every powerful statistic or really insightful chart, there's this hidden world of structure and rules. It's the secret sauce for how we turn all that messy, real-world noise into clear, useful knowledge. So today, we're going to pull back that curtain and see exactly how it's done.
All right, let's just jump right in with this really cool example from The Economist. It's called the REV index. And what it does is it gives every country a single score, just a number, from 0 to 100 that tells you how ready they are for the whole electric vehicle revolution. You can see right away Norway's at the top, with China and Germany close behind. I mean, it looks so simple, right? Super clean, super authoritative. But that's the big question, right? How in the world do you take a huge, complicated idea like EV readiness? I mean, that's everything from charging stations to what people think to government rules. How do you boil all of that down to just one number? Well, that's exactly what we're going to deconstruct here.
So to answer that, we've got to first understand the language that makes this whole thing possible. And that's the language of quantitative analysis. It's really how we make numbers tell a story. And at the very heart of that is something called quantitative data. All it really means is taking parts of the real world, like the number of charging stations or even someone's opinion on something, and turning them into numbers. And why do we do that? Well, it's because once something is a number, we can use all these powerful tools to analyze it and find meaning that was totally hidden before.
Now, here's where it gets really interesting. All of this data, it doesn't matter how complicated it seems. It all basically falls into two big families. And getting the difference between them, that is the absolute key to analyzing anything correctly.
Okay, so those two families are categorical data and numerical data. Just think of it this way. Categorical data is all about sorting things into different groups or buckets. Numerical data, on the other hand, is about measuring or counting actual amounts. It sounds basic, I know, but trust me, this difference is absolutely crucial.
Okay, so let's break down that first type, categorical data. The most basic kind is called nominal data. These are just labels, plain and simple. Think about car engines. You've got petrol, diesel, electric. There's no order to them, right? One isn't better or higher than the other. They're just different categories. But then you've got ordinal data. And with ordinal, the categories do have a logical order. A great example is tweet sentiment. It can be positive, neutral, or negative. You know the order, but you don't really know how much more positive is than neutral. The distance isn't clear. All right, now let's switch over to numerical data, which gets a lot more precise. First up is interval data. Here, the difference between the numbers actually means something. So, for example, the jump from 20 to 30 degrees Celsius is the exact same amount of heat as the jump from 30 to 40. But here's the catch. You can't say 20 degrees is twice as hot as 10 degrees. Why not? Because 0 degrees Celsius isn't a true zero. It doesn't mean there's a complete absence of heat. Now, compare that to ratio data. This is the good stuff. It does have a true zero. Think about company profits. A company making $0 is making, well, nothing. So that means a profit of $2 million is literally twice as much as $1 million. The ratio makes sense. So here's the really crucial point in all of this. The more precise your data is, as you climb that ladder from just labels, like nominal, all the way up to ratio, the more powerful the analysis you can do becomes. It's pretty simple. You can do a heck of a lot more math with company profits than you can with a list of car engine types. Okay, so why does any of this actually matter? I mean, really. Because if you use the wrong kind of analysis for your data type, you don't just get a result that's a little bit off. No, you can get an answer that is complete and utter nonsense. Let me show you what I mean with a quick, classic cautionary tale. So the story goes, there was a student doing research on customer satisfaction across 6 different hotels. To make things easy for the computer, each hotel was just given a number code. Hotel 1, Hotel 2, all the way up to 6. The researcher then just plugged all this data into a statistics program to see what it would say. And the software, it did exactly what it was told. It crunched the numbers and it spit out a result. It calculated the mean, the average, of all the hotel codes people visited. And that number was 3.74. Which leads to a pretty ridiculous question, right? What on earth is hotel number 3.74? I mean, is that a broom closet somewhere between the 3rd and 4th hotel? Of course not. It doesn't mean anything. And that right there shows the mistake perfectly. Those hotel codes, 1 through 6, they were just nominal data. They were labels, not real numbers. You can't calculate the average of a bunch of names. The only thing that would have made any sense was to find the mode. In other words, which hotel was the most popular. But using the wrong tool for the job, the result was a totally meaningless number.
Okay, so we're clear on our data types, but how do you even get the data organized for analysis to begin with? Well, it all comes down to building the right structure from the very start.
And that process starts with what's called a code book. You can think of it as the instruction manual for your data. It's where you systematically go through all your information, you create categories, and then you assign a number code to every single possible response. This is the magic step that turns qualitative answers, like, say, an open-ended question like, what did you like about the restaurant, into clean numbers that a computer can actually work with.
You've probably heard the old saying, rubbish in, rubbish out. And let me tell you, it is absolutely true here. If this coding part is sloppy or you're not consistent, then it doesn't matter how fancy your analysis is later on, it's not going to save you. The quality of your final result is completely dependent on how well you do this prep work.
So the end goal of all this organizing is to create what's called a data matrix. It's a really simple but incredibly powerful idea. It's just a table, like a spreadsheet, where every single column is one variable, like age or gender or income, and every single row represents one individual case, like one person who answered a survey, or in our earlier example, one country. And this is what that beautiful final structure looks like. See how clean it is? It's perfectly organized. Every single little cell has a specific purpose. This universal grid format is exactly what almost all analysis software is built to understand. This, right here, is data that's finally ready for discovery. Okay, so with all that in mind, let's circle all the way back to where we started, that simple-looking chart ranking countries on their EV readiness. Because now, when we look at this chart, we don't just see a pretty picture. We see the end result of a really rigorous, super structured process. We now know that behind those simple bars is a carefully built data matrix, which itself was based on a really well-thought-out codebook. And here, we can actually get a peek at that hidden structure. That final score isn't just one number. It's a composite score, built from a bunch of different variables that are all grouped into these pillars. And look at how they're weighted. Charging infrastructure, which we all know is a huge deal for consumers, makes up a full quarter of the entire score. Then you have affordability at 15%. Each one of these pillars is its own variable, and each has been meticulously coded and measured. And that, right there, is really the whole point. This hidden structure of data, understanding its type, coding it with care, and organizing it logically, that is the secret. That is what lets us take this big, complex, messy reality and distill it down into clear, powerful, actionable knowledge. Kind of makes you wonder, doesn't it? When you think about everything from your credit score to the public health stats you see on the news to the recommendations you get online, what other hidden data structures are out there, quietly shaping your world right now?